Hello everyone, myself Tanmaya Vishnufani and my teammates Devharsha and Sashikant. We have been a part of MSD and we made a project on microwave oven simulation under embedded system. We are from KL University. And coming to the project, we have taken parts of introduction, block diagram, working principles, software used, embedded program in MPLAB X IDE, applications and advantages and disadvantages, and finally conclusion. And coming to the microwave oven, it is a relatively small box-like oven that raises the temperature of food by subjecting it to a high-frequency electromagnetic field. The microwaves are absorbed by water, fats, sugars, and certain other molecules whose consequent vibrations produce heat. Embedded system in microwave ovens. The embedded system in a microwave oven works as a command device. It is designed to take directions from the keypad and turn them into commands. Coming to the microwave oven. A microwave oven is an embedded system that is used as kitchen appliance. It is used to heat and cooks food by exposing it to microwave radiation in the electromagnetic spectrum. And this is a block diagram of embedded system. System code which gives input ports and also stores memory which gives output, and these made the other devices. And this is the embedded system used to create microwave oven. We have fuse, shunt interlock, serial interlock, thermal protection, relay, which is used to which is performed like a switch, controller, microprocessor, magnetron, bleeder, waveguide, and we'll get microwave output. Working principles. Basically, microwave ovens uses electromagnetic waves to generate heat by moving water molecules. When caught in electromagnetic waves, water molecules move very quickly in a counterclockwise then clockwise motion, alternating back and forth at extreme speeds. This movement generates heat energy. The microwave oven consists of high voltage transformer that passes energy into the magnetron, a magnetron chamber, a magnetron control unit, a waveguide, and the cooking chamber. Coming to the diagram, this is a waveguide and this is a magnetron. This is over chamber. This is control circuit where it will control overall microwave oven transformer, and this is the power supply. The softwares required for this project are MPLAB X IDE and also Simlab PIC Genius, which we have been used PIC 16F877A. And our architecture of Simlab. The PIC microcontroller is based on RISC architecture, where its memory architecture follows the Harvard pattern of separate memories for program and data with separate buses. And this is the part of Simlab where CPU and in CPU we have ALU, control unit, registers, which is having input devices and also output devices, where it stores the memory with using RAM, and also data bus, address bus. And our architecture of PIC microcontroller. We have been using CPU with 35 instructions, interrupts, WT, which known as watchdog timer, and we are also having five ports. Those are port A, port B, port C, port D, and port E. Port D is used to interrupts, which can have inputs and also outputs. Port E, which is a watchdog timer, where we can have both inputs and outputs. Coming to the timers T0, T1, T2. Program, and we are also having memory locations such as program memory, which is having 8K, EEPROM with 256 bits, SFR, RAM 368, reset, power supply, which can hold 2 to minus 5.2 minus 5 to 5 volts. And also
Embedded programming. Embedded system programming facilitate the development of consumers facing devices that don't use conventional operating system the way that desktop computers and mobile devices do. Due to the due to its effectiveness, C is the most used embedded programming language. The C programming language is used to create around 80% of embedded device. It is portable, irrespective of the type of processor and structured. Main C. Every C file has a H file. Main C file is shareable file. Main H. These are the header files from the MPLAB X IDE. By writing the program in MPLAB X IDE, there will be a converting of hex file. So the hex file must be loaded to the PIC Simlab to get the PIC 16F877A work. We have to upload the hex file from the MPLAB XIDE software. Applications of the microcontroller in micro oven. The microcontroller inside a micro oven takes input from the keyboard, keypad, displays output on an LCD display and controls a relay that turns the microwave generate on and off, reheating the food, recrystallizing honey, roasting the food items. Advantages of the micro oven: quick reheating, cooking program, easy to clean, reforest food. Disadvantages of the micro oven: dry, soy food, not versatile, need constraints, food poisoners. Conclusion: micro oven heats food in the form of electromagnetic radiation caused by radio waves. Microwaves have three characteristics that allow them to be used in cooking. These are reflected by metal. As electromagnetic radiation occurs, we will be neglecting glass, paper, plastic, and such materials. We are using the MPLAB XIDE from the simulation of the virtual micro oven, and also we will be recognizing the buzzer sound by entering the code and transforming it to be PIC 16F877A for further instructions sent to the oven. Micro oven will be uploaded along with the advancement of technology and its future uses. Thank you, Emertxe Technologies, for your guidance and for this golden opportunity to the students. I have taken MPLAB XID software version 6.15. So let us wait. The software is opening. It will take some time. So our project microwave oven is completely written in this software only. So you can see the software is open, and here I have created a project title microwave oven project. Here you can see that all these files are loaded into this software. It contains header files, important files, linker files, source files, libraries, and other loadables. It also can the software our project mainly contains main.c file, main.h file, isr.c file, and you can see here this is the main.c file, main.h file, the code that we written, and the matrix keyboard file and other timers file that are required for our project. So after loading all these files and after writing all the programming, the next step we need to do is we need to build. So as you can see, I'm building this. Here we have got build successful. That means our project is completely error free. So I can proceed for further simulation in PIC Simulator, which you will be seeing in further seconds. So coming to the working of PICLab simulator, as you can see, I have taken PIC Genius, under which the model number is PIC 16F877A, which is vastly used in microwave applications, oven applications. As you can see here, there are many options like file, board, microcontroller, modules, tools, help. So based upon your requirement, you are need to select the type of board that you use. Since I am using PIC microcontroller, I can take PIC Genius and the module, and the microcontroller is PIC 16F877A. So after loading all this, go to file and you need to load the HX file. As we can see, I'm loading the microwave.hex file. After loading the hex file, switch on. As you can see, the microwave oven is on. It can work in 4 modes: micro mode, grill mode, convection mode, and start mode. So before going to this operation, you can see there are a matrix keyboard on the matrix keyboard on different ports like USB port, PS2 port, and serial port, and 480 RS485, and a cooler with an buzzer and 2 different relay modules. So let us start the operation. So by pressing the one, we can go to micro mode. So let us press one. So I switch to micro mode. So here we can set the time for the microwave oven. For suppose, let us set for 25 seconds and hit the enter button. That is, click the hash button. So it will, from 25 seconds to 0, it will take time. And after completing, it will give a indication of a buzzer sound. So which you can all listen. For here, in order to start or resume the operation, press 4. For pause the operation, press 5. For stop the operation, press 6. So the time is completing. Let us wait for the buzzer sound. It has given a message as time up with an buzzer mode. So this is the operation in micro mode. Same as now coming to mode 2, it is a grill mode. Here also we need to set the timer. I am setting as 20 seconds. So press the enter button. Here I can pause the operation. As you can see, the operation is paused, or I can completely stop the operation. In order to resume, I need to press 4. So the operation is resuming, and the cooler is moving, and buzzer is on. So let us wait. Time is up. The time is coming. It also indicates time up as a message. So these are other 3 modes, that is convection mode, and 4 is the start mode. In convection mode, we can see we can set the temperature as per required. So let us set for 33 degrees Celsius, and I'm pressing the enter button, and we need to wait for the time. So we need to wait for 180 seconds for this. So these are all various modes in this PIC 16F877A module. I hope this you liked our presentation. I would like to thank Emertxe Technologies for providing us this wonderful internship opportunity with with an amazing project. I would like to thank our teammates for their effective work to complete this project successfully. Thank you.